Good morning. My name is Andrew Ogden-Swift. I'm representing the Process Management and Control Special Interest Group of the Institution of Chemical Engineers. I have great pleasure. I'm not going to try and say Niel's surname, so I have great pleasure in inviting Niel to give today's webinar. Niel is product manager with IntelliSense, and he's going to talk to us today about optimizing processes in a way that empowers people. So after the webinar, the slides and a recording of the webinar will be posted on the Special Interest Group website. And then also once Niel has stopped talking and has finished his presentation, there'll be opportunity for you to ask questions. Any questions you have should be entered through the question panel on the GoToWebinar tool. So I'll now hand over to Niel.
Thank you very much, Andrew. Hey everyone, thank you for joining. I see we're at about 31 people. I'll switch off my video as soon as I start, just for bandwidth purposes. But yeah, I'm Niel Knoblauch, product manager at IntelliSense.io, as Andrew said. My background is in chemical engineering. This is why I'm affiliated with IChemE. Started my work, my career after doing a master's degree in control in minerals processing. I started working in the advanced process control space, particularly in the mining industry, minerals processing and metallurgy, and then joined IntelliSense.io in 2019, focusing on process optimization, but I'll say a bit more about that in a bit. I'm going to switch off my video now and then get into the slides. So first, an introduction on IntelliSense.io. We are a global distributed company, started in 2016. We have clients around the world, all the way from Latam, Chile, and Brazil, etc., to Africa and Australia and Kazakhstan and Asia. We focus particularly on the mining industry, so we've decided to go vertical, focusing on doing scientific AI to optimize or maximize net metal production. So we are solving pain points across the value chain to improve people's operations. Now we are all distributed across the world. I'm joining from South Africa. So our product suite focuses on optimization applications, all the way from stockpiling to grinding, flotation, thickener, leaching, and solvent extraction. And so yes, this is we're very much focused on the mining industry. But those of you who joined, maybe think centered on other or working in other industries, the minerals processing and metallurgy is very similar to other process industries. The main difference likely being the variability you're getting on the feed side, meaning that it's just high. The similar control and optimization systems just go through a bit significantly more disturbances, and the challenge is so much more. And so this is why we are focused on solving these problems to help mines become more sustainable, safe, and efficient. So that, in a nutshell, is IntelliSense. I'll share my contact details at the end if you are interested in you have more questions. In this session, I'd like us to take a bit of a higher level view, and I'd like us to unpack the crucially important task of doing process optimization today in our different industries. So whichever industry you are working in, I'd like you to consider that, even though I will provide examples from minerals processing. And I believe that this is the core task of chemical engineers and other adjacent roles. So let's just start by defining optimization. I've looked at quite a few dictionaries. It said quite very different things. And I've decided to distill it down to making or letting something best serve its intended purpose. So letting something do what it's intended to do as well as possible. If we then look at process optimization, we can say that this is getting a process to do what it's supposed to do as well as possible. And again, I believe this is the core task of chemical engineers. But as we heard last week, those of you that joined last week's webinar, there are multiple ways to define what a process is. What do we talk about when we say a process? We can be speaking about a set of assets or equipment, designed unit operations. Perhaps we consider the people and the IT systems that are part of this. Everything has an impact or influence on the changing the feed material into a product of a higher value. So in that sense, we could potentially better speak about an operational optimization, combining both the process and people, and saying that the sum of these need to best serve its intended purpose of changing some kind of raw material, whether that is crude oil or mined ore, etc., into a on-spec product of higher value. So you can see in the middle, we've got the process and then the operation around it, which involves people as well. Now, there are different, the core focus of this is getting equipment and assets and unit operations to work together in a way that it transforms this feed material. So if we were to assume that the feed is given, there's some kind of feed material. In minerals processing, this would be crushed ore, for example, and there's some kind of product spec that we need to achieve. In between this, we have the operation. And we can ask the question, how can we best make sure that this serves its intended purpose as well as possible? That's doing optimization. Now, if the feed properties never changed, if we had a constant feed rate with the constant feed properties and a spec that never changed, this decision, and I think optimization is in the end a set of decisions. The set of decisions needed to be made only once, and essentially this is what design is: deciding on equipment size, kinds of unit operations, redundancy, circuit design, designing the process itself, and then people's workflows around it to best transform this feed material into the valuable product, most profitably, most sustainably, most safe. But we know that the feed is not homogeneous, particularly in the mining industry. We know that the earth is not homogeneous, anything but, and constantly changes. Other things happen, equipment breaks, feed production is disrupted, and it's unstable. On the market side, we know that market conditions keep changing. There might be a downturn in China, gold or copper prices change. Some cartel, something pushes up the oil price. Both the feed and the demand sides change. And this means that the process optimization question fundamentally changes all the time. And the decision of how to best operate the process needs to be made all the time, bringing us to the category of real-time optimization. This means that people need to constantly re-ask the question, the optimization question: how should we operate to optimize the processes, optimize to the process's changing purpose? And this is a whole cascade of decisions, turtles all the way down, assuming the physical process is in place and it's been designed, taking this as a given. Then there are a host of questions to be answered. When do we do maintenance? How do we make sure that the process has maximum availability and utilization? How should I run this process in order to optimize or to achieve my process KPIs? And which KPIs should I target? What should be my control set points? How should I stabilize the control system? Yes, and the control question: how do I stabilize my plant in face of incoming disturbances in a way that I keep my plant safe and stable? There are many decisions to be made on a daily basis. Now, just a brief history. So when mining started, so what you see in front of you here is a diagram of a typical and simple flow sheet of changing what you'll typically find in a minerals processing plant or concentrator, changing the feed ore, doing size reduction on it and separation, and dewatering to end up with a dry concentrate and dry tails, which can then be refined further. All decisions, the ones that I mentioned, all the way from kind of when I changed my valves for stabilization, all the way up to how should I operate this in terms of set points, all these decisions used to be made manually. I mean, when I did some research on this, I realized that people did ore sorting by hand. So it started off very manual, opening and closing of valves, when to do maintenance, and many of these decisions were very fast. And we now know that stabilization, particularly for inventories, levels, and high precision flows, etc., it's best to do this sub-second. So imagine people doing this. So this brought about the world of control, PLC, DCSs, simple decisions being made fast, relieving people of the tiring need to do this. Control came about. First, lower level decisions were given to machines. For example, how should I change the water valve to get my desired water flow rate? These single input, single output kind of decisions, which later, as APC, Advanced Process Control, improved, became multivariable. For example, doing mill discharge control, knowing how to change cyclones, valves, water addition, everything together to stabilize your product, your grinding circuit product, for example. And so I think APC is doing very well, and other industries have contributed to maturing these systems in the market. And this brings us to today. And as you can see here, the task of optimization, the human decision making is very much still there to decide what set points should these APC systems pursue. How do I operate each section? What should be my grinding product particle size target? What kind of grade should I target on my flotation circuit? How dry is dry enough for my dewatering circuit? And I think here I want us to realize that if Henry Ford said if I asked people what they wanted, they would have said a faster horse. And I think today, if we say what do plants really need, we would be tempted to say that plants need better control systems, better APC systems, so they can take over everything. And in a sense, we would be extrapolating the path of improved process performance and optimization we've had until now, further towards the whole circuit. My own journey tracks this process from control to optimization. As I mentioned, I started my career in APC, developing APC systems for minerals processing, advanced PID controllers, robust nonlinear model predictive control. And we went further. I remember going into real-time optimization, trying to solve linear equations at steady state to see where processes should operate. But in this way, what we did essentially was to pursue this larger control systems picture. And in the server room, the systems would try to find a new optimum. And these RTO systems struggled to gain traction. I joined IntelliSense in 2019, a company that decided they want to do process optimization only. So we focused on improved process transparency, making better decisions. With my control background being a hammer, I just saw nails and told the team at that stage, let's go all in on control systems and pursue this one big, great control system. But over time, we learned, I learned a learning posture. And I think what happened was that I realized that the human decisions that people make today are complex. They are large scope, multi-team decisions with slow feedback loops. And this brought me to a clash of two things. The first one being extrapolating control systems thinking. I had all these solutions in my hand with the momentum of the industry, expanding the domain of APC, We have the tech, even now introducing artificial intelligence, neural networks, etc. And I had a clear vision of the systems that we needed to build to do process optimization, which is different from operational optimization. And the second part was, as I spoke to people on the sites making these decisions, I realized that they are already doing this every day, and they have particular pain points. At IntelliSense, in the early years, we developed this sexy technology, remarkable solutions, but nobody used it when we were still very much solution focused. Because, and this is what we learned, that we were not introducing process optimization to these operations. People have been optimizing their operations every single day, every shift for decades. And we got there trying to drop a solution. And so I think what I've learned is that when you observe how people make decisions on the plant, for example, metallurgists, process engineers, mine planners, and in other industries, this will be slightly different roles. You realize that there's actually a lot of conversations going around between different people over radios. People observing data, knowing what the froth looks. If the froth looks like this, it means this. Lots of interpretations going on outside of their data systems. And many of these people have decades of experience, if you will, mental models in their minds. I can now see that what we've done over the past few years at IntelliSense was pivoted from developing technologies for process optimization to driving operational optimization. And I'd like to share two practices that have helped us make the change. So this is what I shared earlier with human decision making around the control systems. And what we are focusing on at the moment is asking the question, could we provide better set points to stabilizing control systems by augmenting the decision making of people on site, by letting them set the objectives, the highest level objectives for their process, and we work with them to solve their pain points to improve their optimization. So I'm going to share two practices with you. The first one that I want to share is leading with the requirements. This brought about a difficult shift in my mind. As a chemical engineer and a technical person, I like to see myself as a technical person. Before I thought if I just designed better technology with a great spec, we can just go plug and play. And there was a move in my mind to value-led instead of solution or technology-led development. So if operational optimization involves both people and their processes, it's important to consider both how we would empower the operation, the whole operation, to better serve its intended purpose. So starting with the process, so there are two parts of this, the process and the operation. If we start with the process itself, yes, we need to make sure that we implement and do everything that we've learned. Check for define your system, do a degrees of freedom analysis, check for observability, controllability, do flow sheet analysis, know which variables you're talking about, what is the purpose of the system boundaries that you've set, and really understand this process. That's always the best place to start. But then the second part of this, the second part of operation, is human workflows. We need to understand the workflows of people on site. If we're going to go in terms of with empathy, we need to know how people interact. What are their goals? If the different people so in the minerals processing space, we might speak about metallurgists or control room operators or mine planners or process engineers. We need to know what are their goals. What's their daily workflow? What does a day in their life look like? These people are often the advanced sensors, the optimizers, the set point setters, the performance target negotiators, the forecasters, the alarms and the responders. They make for an intelligent human system, knowing the process by heart. And so if I take you through an example of storyboarding, so this is an example of just the exercise we did to map out the role of the process engineer on site. And this has been quite helpful actually to engender empathy within our own team, developers and data scientists who might not have been on site yet. So the process engineer gets into the office a little stressed in the morning as the team is behind their monthly plan and there are reports of a challenging night shift. There's an early morning meeting. They try to understand what happened. There's a lot of blame shifting, lack of clarity, taking up a lot of time. No, it was you. No, it was the pump. No, it was this. Today's feed plan seems clear, but Brian, we call him Brian, knows what the plan gets, that the actual plan, what the plant gets will be different from the plan, and not all the properties have been filled in. So they're unsure about the root cause of underperformance. They're not 100% sure what the process will get, and based on what might have messed up yesterday's performance in the plant feed, all just guesses at this stage, Brian decides to make some changes to yesterday's set points. Maybe run at a higher, rougher mass pool on the flotation circuit, push more frother. This was a flotation example. Bypass a particular cleaner flotation cell with a broken dart valve. These are the kind of decisions. And the engineers and the operators in the room tentatively agree, knowing that they will likely have to ignore these set points when the real feed comes and they will see how the plant performs. So they're like, yeah, sure, buddy. We know this is not reality. Operators also wonder how Brian decided on these changes, and they would perhaps want to do something different. Brian ends the meeting, unsure if he made the right calls and whether the team will in fact follow his guidance. And tomorrow morning he will again hear what they actually did. Not quite sure what can be improved. So this is an example of as a storyboard. Obviously, it's the generalization, and for a particular site, this will be much more specific and a few pages of intel. The next step then is and so you can see that we are leading with value and leading with improving the operation. Next, we guide like an envisioned workflow. So if their pain points were solved, let's design a better future together, the dream. What would your job look like if your pain points were resolved and you could achieve your goals? For example, the operator keeping the plant stable and fine. So we can run through a similar exercise. And this is intended to be rather solution agnostic, so that we focus on leading with in empowering a better workflow. So before the morning meeting, Brian checks in on how the flotation circuit performed in the past 2 shifts and identifies possible root causes to be discussed in the morning meeting. He's on the front foot as he already has good hypotheses about what happened. Brian then reviews the performance of the last 2 shifts with his team. So the morning meeting with BrainsApp open. BrainsApp is our platform on which our optimization applications run. They walk through the specific periods of underperformance and quickly agree on what happened, what can be done to improve it, including the times when the operators ignored the optimizer's recommended set points. So this is assuming that there's some kind of system, as we have, that provides recommended set points, and they can actually check the extent to which these were followed, and if not, why not. Brian can see that the feed plan is on BrainsApp, so submitted by a geomet or blending team. He makes small adjustments to the optimization system's priorities, asking for a slightly higher grade, as the feed will be higher, grade will be higher, and they'll get paid more. So Brian makes some changes to his circuit and updates the value driver, which communicates his KPIs for the plant. He talks to his team this time, and he highlights things that they need to look out for, and it's quite clear to them and transparent to them how his rationale, and his team is confident that the optimizer will update automatically as the feed changes and will alert them as soon as anything goes wrong. That's an example of a storyboard. Okay, so now that we've got an as-is picture and envision picture, again, we would do this for per site as well. This is just generalization. What we then get to is we can compare these two And typically we do what we call user story mapping. So what's the difference between these two pictures? And how can our app come alongside them to make this new picture possible? For example, knowing the feed that will go into the plant is quite a big one. So we can have a user story around, as a operator, I would like to know what the feed's going to be over the next hour, so that I could make changes in response to this anticipated change. So I'm ready. So the plant is set. Plant is adjusted prior to these changes coming to my plant. And we have a bunch of these. There's a whole kind of lots of material you can find around user story mapping, but for me, this has been a big enabler to move towards focusing on leading with requirements and value in our product development, as opposed to leading with features and trying to find use cases. I hope that doesn't sound too familiar. Okay, and in this way, we come alongside the optimization that is being done already, focusing on what's wrong or can be improved and empowering them to do better. So in the past, where we would have come in with this solution and bulldoze some people, no questions asked, we learned that we learn with people, and our development and our implementation ends up making one continuous improvement loop. And so instead of having one line towards the new state, what ends up happening is we have continuous releases, each of these empowering an improvement, solving a pain point, so that we deliver value quickly while developing our product and getting feedback along in the process. Now you might ask, Niel, you're assuming that people, operators, etc., are part of the future of the industry, assuming that people will be relevant and an ingrained part of operations in 10 years' time. Now, to me, this is one of the most challenging questions of our time, and one of the main questions being asked of our generation today. How will we address this question? How we address this question will determine the future of work. And I am not sure what this will look like in 10 years' time. What I do know is, as chemical engineers and other people focused on process optimization, our sole pursuit should be value, in making sure that processes and operations that we are responsible for improving are best doing what they should, making them more profitable, do less harm to the earth and people, etc. Focused on value and not any other agenda, including the agenda of automation. I do think we live in a time of automation everything, self-driving cars, people-less paying, ordering, eating, anything. We're automating everything we can. And while this might end up being the best solution long-term, I do not think this should be our pursuit. Automation should be one of the tools in our toolbox in service of optimization, which we approach with curiosity and humility. This has been my journey. And as we focus on value, I believe we will, as I've done in my career so far, reach a point that we would not have foreseen before, perhaps creating a new category of solutions that we might not have dreamed of in our papers, in our sci-fi. One more thing on automation. It's a bit of a different flavor. My father-in-law has a Ford Ranger. We call it a bakkie in South Africa. You might call it a truck or pickup. It's quite nice and fancy, and it has this option to change from manual driving to assisted driving. So you put on, in doing so, it basically operates like a MPC or APC system with 3 objectives: cruise control, follow control, and keeping within the lanes. And when I switched it on, I was like, oh, is this self-driving? Is this a self-driving car? And something in me was intimidated, even irritated at the nerve of this thing to drive on my behalf. But I tried it, and I took my hands off the wheel. But after a while, it told me to keep my hands on the wheel, likely because it wasn't sure of something. Maybe there was a pothole, of which we have quite a few, or the lane lines went dimmer at a specific point. And it asked me, as I was looking on this console in front of me, it asked me to keep your hands on the steering wheel. Were I to disengage completely and let it run without me hundreds of miles, if I were to go sit at the back while in this mode, if it were suddenly to tell me to take over, that would have introduced more risk than the value it would have added, making things worse than it would have if I just drove the car all the way myself. This increase in operational risk and fragility is what we could run into if we pursue automation for its own sake. Fortunately, Ford knows that the value of the driver's eyes on the road and hands on the steering wheel, they know it's very important, and it's apt for the maturity of where their software, but also the condition of roads, etc. are. And I'm wondering whether we know this ourselves. Okay, so the next practice that I wanted to share is having a transparent and empowering product. Now, we call this at IntelliSense.io, we use product language, but you might use the wording of technology or solution in your space. Let me just go a slide back quickly. So the focus here is on developing and implementing transparent solutions. If we are focused on operational optimization and not only process optimization, it's important for our product and solutions to be empowering. So if we, with the Ford Ranger example, it's important if we take this car as a product, for it to be sufficiently transparent to the driver of this car, for the driver to remain engaged, to know when they should put their hands on the wheel, know when it's time to slack off, to know why it's slacking off or accelerating, why it's turning left and right, to know what speed I set, so that if it's time for me to hand over, so that number one, I can make sure that if it's not doing what I intended to do, I can take over, because in the end, I'm still responsible for this plant. But secondly, in the moment that I need to take over, so I can do so well, and I'm not completely disengaged, and it will take several seconds to avail myself of the situation that I'm in. In our apps at IntelliSense, we focus on transparency in two areas. So the first one is modeling. So transparent data handling, uncertainty handling, things like error propagation, knowing how an uncertain sensor impacts your outputs. The understandability of causality. There's a lot of, in the digital twin space, there's lots of talk around black box and reducing black box modeling. But also optimization. In the moment, what is it trying to achieve? What is it prioritizing? What's its rationale? Historically, to be able to look back at particular times, what did it try to achieve at certain points? And also, what is the objective function and the limits? This is what we call at IntelliSense the value driver, or rewards. Well, what is it trying to do? And how can I as a person influence this? But the second one is great user experience, not just user interface, HMI, but the experience, as I mentioned, around workflows. And I believe if we center on workflows as a starting point for the people part of operational optimization, that we will do well in this space. So achieving seamless human-machine connection and invisible design. The less you're aware of this, the user interface, the better. Back to the car example, when you drive your car, you should not be thinking about the design of the speedometer. You should just think about the speed, those kind of things. And I mentioned handing over back and failing well as well. Quick screenshot of our optimizer screen, which we give to the control room operator. This is a simple example from our reference data set. So not to show client data, but typical plants have much bigger circuits. But essentially what we do is to provide the control room operator with insight of all the feed data that's coming into the circuit. So on the typical plant on the left hand side here, you'll have the feed rate, the density, or properties, anything that they track from upstream and influencing their process. If there's if there's something that's outside of their data system, they could report these manually. On the right-hand side, there's the performance section. So at the top, they are able to adjust the strategy. We call it the strategy, but in the end, it's the objectives and the limits of the optimizer. So they get real-time feedback on the current state of this, but also the optimized state to see, is my process currently performing well enough? Can it be improved, and what should I do to improve it? We give visibility on what it's trying to achieve. So we are not only expecting operators to follow recommendations, but we are convincing them by showing them that, hey, if you do X, Y, Z, then your performance will improve. And these are the predictions by our models. And then in the middle, we provide control variable set points, recommended set points. So these are the things that are provided to the control systems. Often we start off with a human in the loop where they enter these set points manually, but then go to a hybrid or a full integration where these can write directly back to their system. But similar to a car that keeps even if the Ford Ranger goes into augmented driving mode, still the operator sees everything and remains engaged and is fully aware of what's going on. This stays there in the control room, and they can continue to see this and be engaged. And if anything were to fail, for example, important sensor goes down or something breaks or anything happens, that handover is done well and they know what's going on. If we develop and deliver optimization systems or control systems or with bad user experience, one of two things happen. Either people will win and the system will not be used, or the system will be forced upon people and they lose. And great design makes for win-win. And so this is what we have been focusing on. This is what I've been spending my days on, is seeing how we can come alongside, how we can merge the worlds of process optimization and operational optimization, so that some are not done by the chemical engineers and some by the McKinseys of the world, but we can merge this into one space, because in the end, the focus is the same, is to make this operation best serve its intended purpose. So I'd like to leave us with this thought, which is this quote. I think it's based on another quote, but we shape our technology and then our technology shapes us. And I think it's important for us to reflect on what kind of operations we are creating by the technology that we are developing and implementing and the way we are doing so. Great. I think I would love to hear some questions. These are my contact details if you'd like to get in touch afterwards.
Okay, Niel, thank you very much. Very interesting and challenging presentation. So we already have a number of questions in the question panel, so thank you very much for those. And to other participants in the webinar, if you have questions for Niel, please enter them into the question panel in GoToWebinar, in the GoToWebinar tool. So the first question is it's good that you're working to understand how work gets done in reality on the plant. How do you convince your customers to let you do this design thinking and use user stories with them?
Yeah, I have to say that, first of all, Andrew, would you like me to switch my video on? I can't remember what we decided.
Yes, you can do.
Okay. I think particularly in the heavier industries like oil and gas and mining, people are the people who purchase these systems or sign up for the systems that we develop are often not the users. And so the people who end up buying them are often of kind of a more traditional thinking in terms of I will purchase something and I want to know exactly the spec of what I'm purchasing. I'll pay once a fee and I'll get that, and people people will end up using that. At IntelliSense, what we've started doing was to engage the end users more. So typically we create a focus group of, let's say if we focus on metallurgists and operators, that they are part of the conversation, and everyone loves to be given the opportunity to speak about what their pain points, etc. So typically from the user side, there's no resistance in doing so, and that gives people the opportunity to co-design this solution. Of course, people don't want to just sign up for an R&D project, and this is why we typically have our baseline product, which we have developed so far. So, for example, our grinding optimization application, flotation app, etc. We would typically implement that baseline product and then everyone's happy. But at the same time, to say, hey, we are kicking off a partnership here, and we will do continuous discovery with you. And typically people are quite happy with that. As long as they get that first part and they can sign off the project, office can sign off the project saying, yes, we've hit our KPIs, then we can continue to keep going and discovering the way forward.
Okay. Next question is, how far do you go with trying to change a workflow to something new and better, aided by the technology, or or do you do it more iteratively?
Yeah, I guess this is the revolution versus evolution question, because one can do, and that's not easy, easy decision. I think once we have a particular pain point, it's a combination of understanding the root cause of why someone might be struggling. For example, let's say, for example, on a flotation circuit, many people struggle to decide on how to operate the circuit because the feedback they get is much later. So there will be grade analyzers, or they'll take a sample, take it to the lab, only 2 hours later they'll know what the performance was, and if they make a decision on that basis, then it's too late. So that's then we realize, oh, the root cause here is they don't know real time how the plant is performing. So let's give them that visibility, and then we need to see, okay, but how would they, if they would, so that's when you have the conversation with people, is if you knew real time what the performance of your circuit is, how will that change how you work? Oh, okay, well, actually, then I don't have to wait. Maybe I can make these decisions more regularly, or and so I think there are often these key pain points that has defined the as-is workflow, and if you can solve them, typically you find that you kind of jump to a new to-be workflow. I hope that helps.
Okay. Next question is, are there any obvious and common user stories for mining to streamline the user story mapping with a client, or is it better, or do you find it's better to start from scratch to get buy-in and avoid missing things?
So I'm a product manager, so my focus is on developing the core product, and so I have my own version of the user stories are generic, and I develop them generically, and so we keep getting feedback from different clients about their particular pain points, and so often we would prioritize these on the basis of particular clients. But I do see trends, but it's often possible to generalize a particular pain point. For example, someone might have a problem with the valve, someone else with a pump. Let's say, for example, you are giving optimizers set points, and you're realizing that the people's valves or pumps are saturating, so they achieve 100%, and then you keep asking a higher flow rate, even though it's not possible. On one side, it might be a particular valve, on the one side, it might be a particular pump, but you realize from a product perspective, actually, we need to incorporate some pseudo limits into our optimization system, so that the users can trust that if they were to implement these set points, their their pumps and their valves, etc. The circuit will remain within healthy constraints. So I do try to generalize that. That said, when we go to a client, we take what we know, but we also keep an open mind, because it's a learning opportunity, and we want to make sure we don't get into groupthink and we start imposing our understanding of the industry on the client. So it takes more time, it takes going to the site, but it's the reward is quite big.
Okay, the next question is, it sounds like you have improved your product suite for user experience in mining. How do you then efficiently customize it for various customers' specific use cases, workflows, and pain points?
We are seeing this now across different unit operations. So our apps are more mature in some unit operations than others. And what I wanted to do was basically copy over what we have for one and to the other one, assume that it's similar and keep going. But as we started doing discovery, we realized that there are differences, yes, in the process because of different dynamics, time constants, maybe there are chemical reactions involved. And so we learned that we can keep we transfer our understanding of different roles on site, but what they actually do and the exact decisions that they make and the cadence of these, we are open to that being very specific. And so we would then uncover that and be open to the idea that it will be different for different unit operation. At the same time, if for the same product we learn something completely different, that to me is then a prompt that, hey, I need to revisit our centralized workflows and understanding and perhaps update that, which will then kick off a kind of a validation session with our different engineers working with clients to say, hey, we learned this, is that true for you as well? And very often we'd say, oh yeah, actually it might be. But yeah, doing a kind of moving average of workflows across the industry is not easy. And there might be a time where we find that we end up having multiple versions, but the value of having one is that it can guide the development of one product.
Okay. How do you price in the design thinking activities along with your license fees and installation services for a client? Plus, how do you deal with client subject matter experts saying I'm too busy?
So as I mentioned, we do the implementation. So we do a once-off implementation of the baseline product, and we then do continuous discovery. The service after the initial implementation does obviously involve there's a service side, there's a license side, but what we never leave a client after doing implementation, and so we have a team of we call them our mining technical engineers, who are responsible for different clients and always listening for new pain points. I didn't quite get the question whether it's the client being busy or our own team being busy. If it's our own team, we just see whether we do prioritization and make sure that at least once a quarter we do discovery. If the client says, listen, I'm happy with it, I don't need anything else, all of that we treat as feedback. If people are just happy, maybe what we'll do is just validate that if they're happy and they're 100% using our product, then we will typically just validate things with them. So they might not inform the list of feedback, but once we design solution improvements based on other people's feedback, we might validate that with them. And typically people are quite happy to be involved in the design to know that once they get a product update, they were part of that, and they were part of creating that.
Okay. Next question is, what example technologies and algorithms are underpinning all of this? So, for example, there's a mention of something called scientific AI. What are the little bit more specifics around that.
Yeah. So I realized my webinar was kind of on the softer side of this. I didn't go into details about our products, but we do scientific AI. It's basically a focus on a combination of data-driven modeling and kind of first principle modeling. So we often start with the fact that we as people know things, and in our papers and articles, we have learned a lot about processes. So we typically don't go in only with data-driven modeling or like machine learning, etc. We would typically build some kind of backbone with the fundamental modeling, with a fundamental understanding that we as humanity has of these processes, and then we will typically fill in the gaps or the parts that we are unsure of with machine learning. In some cases we've done both, and then it's creating a redundancy or a sanity checking. For example, in the flotation space, which I'm focusing most on at the moment, there's the flotation optimizer as a combination of first principle and machine learning modeling, because we realized, for example, the impact of reagents is difficult to describe in first principles. And so that's then when we ask the data the questions. And there's a play off between kind of robustness and understandability versus really capturing the non-linearities and the unidealities, which is in the data which we might not know from our knowledge. So yeah, I hope that helps. I'm happy to have a chat a bit more about that. I know that I didn't go deep on that in this webinar.
Okay, does the product suite include some kind of workflow automation features such as those found in Microsoft Power Automate or Salesforce or similar tools?
We haven't focused on that at all. I think no, that's not correct. I think particularly on the mining side, so our SIO stockpile and inventory optimization, we realized that typically the data systems and the integration systems are not in place as well as it is in the plant space, and so there I think we have our platform BrainsApp and our application, our optimization application ends up being workflow automation or integrating the workflow, but yeah, the focus always being on optimization itself. So typically on the plant side, for example, we focus on using the data systems that they have. So either speaking to a person or integrating with their data systems, and we have not focused on doing being a workflow automation centered software.
Okay. What does a typical project look like regarding sort of key steps, duration, what a Gantt chart would look like?
Mm-hmm. So our implementation projects have 4 phases: discovery, execution, calibration, and then commissioning. And so this, and as I mentioned, this focuses on, so discovery is typically getting to know the people's process, the process and their workflows, mapping that out, so that, because I always say before, our data scientists don't model the process, they model people's understanding of the process sometimes. And so really capturing the metadata, understanding to what extent the requirements of the client aligns with our current baseline product, the split that there will be between pure implementation and continuous development. And then we would go into focusing on first implementing the baseline product that we have, whilst potentially, and this is where my team comes in, while they're implementing to develop the core user stories that will be required by the end of this project to meet the requirements. So, and then there's execution calibration phase, and then commissioning. We go to site to make sure that this gets embedded into their workflow. We are seeing more and more that the going to site and embedding happens earlier and earlier, even during development. But yeah, so that's typically what it looks like. So there's this two-tiered, you can almost see 2 streams. The one is implementation of the baseline product, and the other one our development team looks to meet the new requirements, and at the end of that, they're happy and our baseline product is updated.
Okay. What kind of payback time, dollar improvement, and efficiency benefits are your clients in mining typically seeing?
Yeah, so I also didn't go deep on the value. We do aim for a return on investment of 10 times. So that gives us the confidence that as operational conditions change, that will even on the lower side of it, even if there's periods of harder to improve operation, we deliver good value. So yeah, the pricing I don't want to go into. I'm typically not involved in those negotiations, but we typically do investigation upfront to see the potential value delivery, and then make sure that we aim for ROI of 10 times. I do think that gives people confidence. And when we do commissioning, we typically write a report to just check whether during the period of commissioning did we manage to get that ROI, noting that as we go, that value will continue to increase as we work together on refining both the product and improving it being embedded into their workflows.
Okay. And what sorts of control systems, DCS, SCADA, what have you, or historians and historians do your clients typically have, and how do you connect up with them?
Okay. Yeah, so there's a whole host of them, and I think particularly people in the control special interest group will be quite aware of what's out there. But yeah, we're talking about the Siemens and the Schneider and the ABBs, etc. It's quite diverse, and we are not limited by that. We typically, on the input side, connect to their data systems via OPC UA gateway. We have a hybrid architecture, so our systems can either run on premise in a server, or what we call BrainsApp Edge, or in the cloud. And we're writing back, we also use the OPC UA gateway. Typically, when we go closed loop, we do this from with our hybrid architecture. So yeah, we've integrated with everything, but luckily the integration protocols are quite generalizable, so we didn't need to develop particular modules to integrate with ABB different from Schneider, for example.
And this is the last question so far. So to the other members in the webinar, other participants, if you have further questions, please enter them into the GoToWebinar tool. Do you have any comments or observations on cybersecurity of your product suite with your customers' control and other management information systems, in particular when you're deploying in the cloud?
Mm-hmm. Yeah, sure. So we have a cybersecurity team which has done a lot of, which is queued up with the latest ISO standards. I think this is something that's shifting and still being defined in the industry. You'll find that different kind of companies have different corporate policies around these things, but we are following best practice around making sure that in open loop mode, and open loop is when we typically do everything in the cloud. That's when we will not write back to people's on-site systems. We realize that is breaks these ISO standards, and so there what we do is make sure that the people have sufficient visibility that if something were to go wrong, they are clear about it, so they're not acting on the information we're providing them or implementing the set points without being aware of what's wrong. So we go for max visibility on that. And then in terms of our hybrid deployment, where we write back the set points to their systems, we follow the same best practice protocols to make sure that it's correctly firewalled off and not connected to the internet. And yeah, I think that's something that's still being defined, but there is sufficient guidance at the moment, best practice out there that we are following, yeah, looks good.
Okay, so we've now exhausted the questions. So excellent timing, almost exactly on 11 o'clock.
Well
So
done, Andrew.
that's at least our time, UK time. So Niel, very much appreciate your presentation and answering all the questions so clearly. I'd like to thank everyone who came along to listen. Hope you all found it interesting and useful, and wish everyone a successful and happy and healthy, safe day. So Niel, thank you very much.
Thank you very much, Andrew. And I'm aware that this is an ongoing conversation in the industry right now. So if anyone wants to connect, please feel free to get in touch and I'll be happy to chat.
Okay, thank you, Niel. And thanks everyone else. Yeah, bye.
Bye-bye.